All right, let's try an application problem. We're being given the information that f of 0 equals 3, and we're being told that we have the graph of f prime shown. And I wanted to be clear, this is f prime, not f. And then we're told that g equals e to the x times f of x. So that requires the product rule to differentiate. So if they want g prime of 0, the first thing we need to do is differentiate g using the product rule. So we have the derivative of e to the x, which is itself, times f of x, plus e to the x times the derivative of f of x, which is f prime of x. And then we need to evaluate at 0. So g prime of 0 is going to be e to the 0 times f of 0, which they gave us as 3, so e to the 0 times 3, plus e to the 0 times f prime of 0. Well, f prime of 0 we need to read off of this graph. And let's put the axes in here. It's really helpful to see because the graph is confusing without them in. So f prime of 0 looks to be right here at 1. And so I end up with e to the 0, which is 1 times 3 is 3, plus e to the 0, which is 1, times f prime of 0, which is also 1. So 3 plus 1 is 4, and that is g prime of 0. Next question is g increasing at x equals 1? And please justify. So we need g prime of 1 in order to justify. So going back to my original g prime up here, I need to now plug in the number 1. So I have e to the 1 times f of 1 plus e to the 1 times f prime of 1. And f prime of 1 is right here. That is 3. So I have 3e. So the question is, we don't know what f of 1 is. So the question is this greater than, less than, or equal to 0? And in order to evaluate whether this is greater than, less than, or equal to 0, we need to know what f of 1 is. Well, we don't know the exact value of f of 1, but we do know that f prime is positive on the entire interval from 0 to 1. That means that f must be increasing. And since f of 0 was 3, that means f of 1 must be greater than 3. Let me repeat that. If f prime is positive, then f must be increasing from 0 to 1, and therefore f of 1 is greater than f of 0. If f of 1 is greater than 3, that means I have at least 3e plus 3e, which means this value is greater than 0, and therefore g is increasing. Next question. Now they're saying k equals sine of x times f of x, so let's find k prime of 0. So that's another product rule situation. K prime of x equals the derivative of sine, which is cosine, times f of x, plus sine times the derivative of f, which of course is f prime of x. And now let's evaluate at 0. Cosine of 0 is 1, f of 0 is 3, so I have 1 times 3 is 3, plus sine of 0 is 0. So the answer here is just going to be 3. And then the last problem with this application is they want to know if k is increasing at pi over 2. So go back to your k prime, which you were given right here, and let's sub in pi over 2. Well, cosine of pi over 2 is 0, so my whole first term goes to 0. And then sine of pi over 2 is 1, and then f prime of pi over 2, coming up here to the graph, pi over 2 is about 1.57. That is clearly positive. So it's 1 times something greater than 0, which means this is going to be greater than 0. So k will be increasing at pi over 2.